الآن مع محاضرة بعنوان الطريقة الأكثر فاعلية للتخفيف من التغير المناخي، يحاضرها لسيادتكم العالم والباحث الدكتور ابراهيم عثمان، مدرس الهندسة الكيميائية بجامعة الملكة فيكتوريا بإنجلترا، والمصنف من علماء العالم الأكثر تميزاً، ابن مدينة قنا. عمل معيداً بالجامعة وأكمل دراسة الماجستير وتخصص في الوقود الحيوي. حصل على منحة لدراسة الدكتوراه من جامعة الملكة. شارك في العديد من المؤتمرات العلمية بمختلف الدول الأوروبية. أسس مؤخراً قناة على اليوتيوب تهتم بالعلم والمعرفة، وهي قناة علم يوتيوب، ويتابعه ملايين من المشاهدين. ينشر من خلالها علمهم التي تعلمها حقيقة الصناعية الفائدة حتى يستفيد الشباب المصري ويكون ذلك شيئا لوطن ولاده على شكل. فليتفضل مشكورا.
شكرا جزيلا. السلام عليكم ورحمة الله وبركاته. طبعا أنا كلي فخر النهارده ان انا في وسط حضراتكم في المركز القومي للبحوث. سعيد جدا بالاستضافه الجميله دي دكتور حسام والقسم وبحضراتكم النهارده. هتكلم مع حضراتكم عن the most effective way to mitigate climate change. So we all know about climate change. It is a reality now. We all live in the shift of the climate pattern. Like if you look at the top photo up there, like we have the carbon dioxide cycle, where plants absorb the carbon dioxide gas in the atmosphere, and then cows or animals and humans, they consume that plant and then they release the carbon dioxide again, and we have that carbon cycle stable for so many years. If you look here at that curve, we have a stable carbon dioxide emissions over millions of years until 1860s, after the Industrial Revolution, where we found, as a human, we found fossil fuels as natural gas, coal, and oil, and we use them as a fuel. So if you look here, the carbon dioxide emission in the atmosphere was around 280 part per million. And after the Industrial Revolution, the carbon dioxide emission dramatically increased up to now more than 400 ppm. And that carbon dioxide emission in the atmosphere works as a global warming and climate change, and it does that effect that we live in it now. So if over the last 20 years, you can see that 20 years over the last 22 years was the hottest year ever recorded. So, and we can see also the climate change effect in terms of the fire, the drought, and the economic loss. In 2018 alone, there was $131 billion loss related to the disasters related to climate change. That's why we say the phrases now that we are now in the climate emergency. We have to do something very urgent. So one most common here question when you talk about climate change, it says, if we plant a tree, does it help? So planting a tree, does it help with the climate change? So the answer is yes and no. I will discuss this later on. And the most effective way to mitigate climate change is related somehow to the diamond. I don't know if you heard about the phrase that's called a diamond is forever. So diamond is forever. This is like a phrase was invented in 1938. A company called D. Beers, Harry was the director of that company, who was selling diamond. And he was seeing all the sales is going down, declining, and the company is losing. He tried so many marketing campaign to increase the sales again of the diamond. Nobody want to buy diamond. So the sales is going down. So he asked a marketing campaign, can you do any like innovative marketing campaign or idea to increase the sales of diamond? And over 10 years, over a decade, nothing changed until one day a lady called Mary, what she's done, she tried to link the chemistry with emotion. She said the bonding between carbon in the diamond is very strong. What if we link this somehow to the emotion? If our couple, if you and your wife or your fiancé want to do like a very strong bond between you and your partner. So that's why in 1990 the sales of diamond went to the sky. So what happens is she linked somehow a commodity to an emotion. So that's why I just explained the diamond is forever, and she did that phrase, and which is very common now in the US. Why did I mention diamond? Because diamond is linked somehow to the climate change. I will explain this in more detail later on. So when you talk about climate change, the most common agreement in climate change called the Paris Agreement. Paris Agreement, the main objective of that agreement is to limit the global warming or the global temperature by just an increase of 2 degrees by the end of this century. But the question is, can we meet these targets? So everyone is talking about climate change. We need to limit the temperature. We need to save the world. We need to limit the temperature increase by the end of this century by 2 degrees. But can we meet those targets? We will see now. So to answer this one, we need to know what is the strategies to mitigate climate change. What we can do to mitigate climate change and global warming. There are so many strategies to mitigate climate changes. I will discuss the most 2 effective strategies of them. So the first one called conventional mitigation technologies. Conventional mitigation such as renewables. If you use solar energy or wind or even nuclear, those are called conventional mitigations, that normal mitigation strategies. What they do, like this is like similar to fuel switch. Fuel switch, instead of we are using fossil fuel like coal, natural gas or oil, we can switch to renewables like solar and wind and so on. But this is called emission reduction. So instead of we are emitting a lot to the atmosphere, now we are going to emit less or none. So those technologies called emission reduction. Okay? But emission reduction in itself, it's not enough. So emission reduction is not enough. Now we are in the climate emergency. We need to remove some carbon from the atmosphere. So we have a blanket of carbon dioxide in the atmosphere, and this causes global warming and climate change. It's not enough to reduce our emission. We have to remove some carbon dioxide from the atmosphere. Okay? There are so many technologies in this area. There are 9 technologies to remove carbon dioxide from the atmosphere. The most simplest way of them is the afforestation. Afforestation, we can grow a plant or we can grow a tree. But tree is like human. They grow, and while they are growing, they absorb CO2 from the atmosphere. While they are growing, they suck or they absorb CO2 from the atmosphere. But at some stage in their life, they plateau. They stop absorbing CO2. And if you leave them like this, they will die and decay, and then they will release CO2 again to the atmosphere. Okay, and if you leave them to decay, they could release also methane, which is a more potent greenhouse gas than CO2. I think it's more powerful in terms of global warming potential than CO2 by 87% in a shorter term. So planting a tree could be could be bad idea for climate change. Okay, why? Because the carbon in the tree is not stable. At some stage, it's going to be decay and it's going to go back to the atmosphere. That's why a technology called biochar. Biochar is similar to the charcoal. What we do is we take the tree and we do pyrolysis and we produce biochar. Okay, similar to charcoal. And what is the beauty about biochar is the carbon stability in the biochar could resist thermal and biological degradation for hundreds or thousands of years. So now we could solve this problem. We could take the carbon dioxide from the atmosphere, use the photosynthesis, using the plant and photosynthesis, grow the tree. Now we can do what we call pyrolysis, and we produce a biochar. The biochar, the carbon stability in biochar, we could fix or lock the carbon in the biochar for thousands of years. And that's done. I don't know if you heard about one technology called DAX. DAX is direct air carbon capture. This is like a big engineering fans. They extract the air from the atmosphere, and they extract only CO2. So they can just take all the air, extract CO2, and they can maybe inject it in the underground. But to remove 1 ton of CO2 from the atmosphere using DAX, it costs around $700 to use DAX. If we use biochar, the cost could reduce by 10 times, could be around $70 or $50. So as we mentioned here, afforestation is a good idea, yeah, but it's not, it has to be rightly managed using thermochemical process like pyrolysis to stabilize the carbon in the tree. And that's why I talk about diamond, because diamond and biochar, both of them are made of carbon. But the question here, not all biochar are the same. So I can produce biochar which could last for 100 years, and then it will decompose and go back to the atmosphere. I can also produce biochar with different parameters and conditions, and it could last for thousands of years. That's why in Queen's University Belfast, we have now a course. It's called carbon fraud. Carbon fraud, like this is like similar to the how to detect the good carbon from the bad carbon, like, or the fraud carbon. So, and if you produce biochar like this, as I said, not all biochar are the same. Like, you can't say, oh, that's very simple process. I can grow a tree, take the tree, put it in the pyrolysis or in the furnace, and I'm going to produce biochar. Now I'm helping the climate change. Now, it doesn't work like this. I'll show you now. When you produce the biochar, like when you take the plant, you put it in the furnace to produce a biochar, there are various parameters here. Like in terms of feedstock type, what feedstock you are going to use? Is it herbaceous wood? Is it woody biomass? Is it algae biomass? The feedstock, it affects the process or affect the biochar characteristics. What is the temperature you are going to use? What is the residence time? How long you are going to leave the biomass inside the reactor? What is the particle size of the material? What is the carrier gas? Are you going to use nitrogen, CO2, or in vacuum? All those parameters affect the biochar characteristics. What is the heating rate? And other parameters like the pressure and the biochar engineering. So as I said, not all biochar are the same. So how do we know the carbon stability? I just mentioned about carbon stability in biochar. Yes, if you take biochar and you can use it in climate change, there are market now for this. Like there are like something like EBC, European Biochar Certificate. If you, as a company producing biochar, they come and they check your carbon in the carbon stability in the biochar, and they give you a carbon credit certification. For every ton you produce, I think they give you $120. But how do we know the carbon stability? How do we know that this biochar is going to last for 100 years or 1,000 years? We know them from the chemistry. Now this is the chemistry part in this project or in this work. How do we know the carbon stability in the biochar? From the hydrogen to carbon molar ratio. So you do CHNS. I'm sure all of you heard about CHNS analysis. Once you do CHNS, you take the hydrogen to carbon molar ratio. If it is below 0.2, then you are producing the best quality biochar ever. This biochar is going to last for more than 1,000 years. If the ratio is between 0.2 to 0.6, then you are producing biochar that is going to last 100 to 1,000 years. If it is 0.6 or more, then this is a very low-grade biochar. This is a bad biochar for climate change. So we've done one in our lab in Queen's University Belfast, and we sent the results to Eurofin. This is a certified lab in Germany, and the results came, I don't know if you are going to see it here in the red market, came 0.43. So 0.43, this is the second best grade in the biochar. So it's gonna last between 100 and 1,000 years. That's why we did our experiment in the lab and in the pilot scale for at least 3 years just to get this value below 0.2. So we can say that we are producing the best quality biochar for climate change. So as I said, that this is one factor, carbon stability in the biochar. The second factor is organic contaminant called BAHs, polycyclic aromatic hydrocarbons. There are 16 of them. You have to track all of them, because by the end of the day, you are going to take this biochar, you either use it as a fertilizer, or you take them, you use them in water filter, or in supercapacitor, or whatever. You can use them also in animal feeding. So in order for you to put them in the land as a fertilizer, the biochar has to be clean. Doesn't have, so it has to be free from any organic contaminant, because organic contaminants, those are carcinogenic. So also there are various classification. The best quality of biochar, it has to have all of this below 0.4, I think, to use them for animal feed. If it is between 4 to 6, you can use them in agriculture, 6 to, and so on. So again, the best biochar has to have high carbon stability and low organic contaminant, and also trace metals, like heavy trace metals like lead and so on. So you have to produce good quality biochar, and it has to be free from any organic or trace metal contaminants. So how do we know this? We go and study the mechanism. What is the mechanism of the BHs, the organic contaminant formation? Like they form from primary decomposition to secondary reaction and so on. So this is the chemistry part in that project. As I said, you have to make a very good stable carbon in the biochar and also free from any organic contaminants. And you have to know the mechanism, how this is formed. So now at Queen's University Belfast, so in Queen's University Belfast, they have a department called Chemistry and Chemical Engineering. So they have a chemistry department and chemical engineering in one department. And I think this is the only department or only university in the UK that has both of them in one department, chemistry and chemical engineering. Why they have both of them? Because say you have a good idea about a project. As a chemist, you can develop the idea, the novelty. But how do you scale it up? So you go and you make a factory, or you go in industry. So you need to know the engineering part, the scaling. So that's what we call it, biochar engineering. And this is a pilot scale that we developed over the last 3 years in Cairo here. So what we've done is we have a software called ACTIS, Advanced Kinetic Thermochemical Software. That software, what it does, it takes the thermal degradation of any biomass, and it calculates for you the kinetic triplet. What is the reaction rate, all those kinetic parameters. And we take those kinetic parameters and we feed them to an Aspen model. Aspen model, what it does, it answers a very basic question. So say you make a factory of making biochar, and you want to answer one very simple question. Do I need heat? Do I need to give do we need heat for this project to run, or we producing surplus heat? So to answer this question, we have Aspen. This is an engineering software where you can feed the kinetic parameters from ACTIS to that software, and it answers this question for you. And we published this work last year in Cleaner Production Journal, and we found out that we produce surplus energy. So that's why if you work in biochar, you have 3 main type of revenue. You sell the carbon credit from Europe. If you're producing biochar, like you have a factory and you're producing biochar, you sell the carbon credit certification, or you get money for that. And you can sell the physical biochar itself. And the third one is you can sell also the renewable electricity, the surplus electricity as heat or electricity from that part. So you need to know the engineering part of that project as well. So I will summarize here with, in terms of biochar. So say you said, okay, and now I want to work about producing biochar for climate change. So we've developed what we call it holistic decarbonization system. Holistic decarbonization system, first of all, we need to optimize what we call it production optimization. So what is the best parameters to produce biochar? What is the best temperature, residence time, throughput, and so on? So what is the best production parameters for the biochar? We use like software like DOE and other software to optimize this process. Once you produce a biochar, you need to know the characterization of the biochar. What is the surface area, the porosity, the pH's contamination, and so on. So you need to do some characterization. Once we're happy with the characterization, we don't have any organic contaminants and so on, we can feed the information to the Aspen model to do the process modeling. Do we have surplus energy or not? Once we are happy with this, we can now, we do all this, the whole process for climate change. So what is the environmental impact of this process? We calculate this using LCA, life cycle assessment. There is a software, I think, called CIMA Pro. So it calculates the environmental impact in terms of eutrophication, CO2 emission, like how much CO2 we are going to absorb from the atmosphere or we are going to remove from the atmosphere using biochar. So we do this with the LCA. Once all of this is fine, now we can go to do the economic model. Economic model means the profitability of the project. What is the NPV, net present value, the IRR, risk analysis, Monte Carlo. Like I'm not specialized in economic model, but over the last 3-4 years, I work with economists, so I knew some information from this. So the most critical information is what is the NPV, what is the IRR, like how many years it's going to take until you return your money, called IRR, and net present value, what is the point where your project it's not making money or losing money, so called NPV, and so on. But the question now, if you do all of this, and that's fine, you take, for example, like in our paper, we take the olive tree pruning, and we produce a biochar here. The question now, we've designed the lab scale work, and over the last 3 years, we finished working on the pilot scale that I showed to you, and now we are going to go commercial. If you go commercial, you are going to produce 10,000 tons of biochar a year. So imagine the quantity of biochar, 10,000. You need to find an application for the biochar. But not any application. You have to see an application where the biochar does not degrade. Like you cannot make biochar for climate change and use them for power. You heat them or you burn them for power. So it doesn't make any sense because the idea of using biochar in climate change that I take or I remove carbon dioxide and fix them or lock them in the underground, or what we call them carbon sink. So not any, like you can, as I said, you cannot use a biochar in power generation. I cannot use them for barbecue or because you are going to burn the biochar and remove or release the CO2 again to the atmosphere. So there are specific applications where you can use biochar for climate change. One of them is agriculture. You can use them as a fertilizer because biochar is not going to degrade over there. You can use them in energy storage, where you can use them in supercapacitor and so on. You can use them in environmental remediation, and we have worked with Professor Hussam here to use them in the water filter. So, because if you open the water filter, you found a carbon material inside it. You can use them in anaerobic digestion. They increase the biogas yield and so on, and they remove H2S contaminant. You can use them in building material. We have a project now with Emirates in Dubai. They make what we call it smart brick. Smart brick, biochar has insulating properties. So if you use them in like making a brick, that brick will work as an insulating material. So it will reduce the air condition cost per building. And it's going to be light, and it will have the same strength. So this is a project we do now with in Dubai. Composting and animal feeding as well. So you can feed the biochar to the animal, but as I said, it has to be clean. Okay. So there are various applications of biochar if you use them for climate change. And this is the if you want any further read. So that's it. Thank you.
نشكر الدكتور أحمد ابراهيم عثمان على محاضرته القيمة، ولو في أي حد من حضراتكم ليه أي استفسار. ميكروفون لو سمحت.
ميكروفون. Thank you so much.
And it's really interesting. I have a question concerning the pie chart. You kindly mentioned that it's categorized in different grades. One of them lasts 100 years and extended to up to last 1,000 years.
Yes.
And the other grades downward. So my first question is, how can you categorize these species of pie chart? The second part is that in case they are categorized so why didn't you from the beginning enhance its properties to be acting such as grade A, which has lasted for 1,000 years? Does it correlate to the origin of the pie chart itself from other ways or by Earth's conditions? So kindly clarify for me.
Yes, yeah, that's a very good question. So I remember when we start producing the biochar in 2019 at QUB, so we found that the stability of the biochar was grade B. So we've changed the condition, the pyrolysis reactions, throughput, and extraction of gases. So say, for example, when you produce B, which is organic contaminant, we just extract the gases, the pyrolysis gases in situ over time. What if we increase the rate of that removal? So we've done this, what we call the production optimization over the last 3 years until we found out that yes, we can now we go from grade B to grade A. But who did that grading? This is the EBC, European Biochar Certification. These are the institution that they do. This is a grade A and it has to meet such characteristic, grade B and grade C. But we found out also there are some feedstock you cannot do anything with them. Like so, say for example, like anaerobic digestion. If you have trace metals, say you have lead, and we have increased concentration of lead, we can't do anything with it. So we can't use them in climate change mitigation. Yeah. Thank you.
شكرا لحضرتك. استمعتي اسئله كثيره بس خليني اخذ هذه سؤالين فيهم. تحديد انواع البايوشار اللي حضرتك ذكرتهم كنت هتكلم عن اهم نوعين فيهم، لكن حضرتك ذكرت حاجات كثيره من ضمنها الاورجانيك كونتامنتس وغيره وغيره. بس هل الاورجانيك كونتامنتس يعني انا شفت حضرتك في مساله بيطلع اسمه وغيره، هل الاورجانيك كونتامنتس ليها تاثير على تحديد جوده البايوشار؟
طبعا حضرتك الاورجانيك كونتامينانتس في البايوتشار بتحدد انت هتعرف تستخدمه فين. يعني انا هستخدمه للانيمال فيد، الاورجانيك كونتامينانت لازم تبقى اقل من 0.4 ككونسنتريشن. طب بنعرف الكلام ده من فين؟ من لما بنبعت العينات ليوروفينز في المانيا. بيدي لك انا بيدي لحضرتك هنا البي اتشز طبعا.
كذلك اثناء الديكربونايزيشن وغيرها. يعني شفت حضرتك في بعض السلايدز طالع الاورجانيك سلايدز زي اس او 2 وغيره، لكن حضرتك ما ذكرتهاش في تحديد جوده البنشر.
تقصد حضرتك الان اورجانيك كونتامينانت؟ ما احنا انا ما ذكرتهاش هنا في السلايدز، لكن هي في التريس ميتالز مهمه جدا. يعني دي لو التريس ميتالز حتى الاي بي سي لما بيحطوا السيرتيفيكيشن بتاعهم بيحطوا للاورجانيك والان اورجانيك. احنا اتكلمنا ليه على الاورجانيك هنا؟ لانه ده في ايدنا نقدر نغيره. انا اقدر ازود الشفط بتاع الغازات، اقدر ازود درجه الحراره، اعمل انسوليشن كويس، اتخلص من الاورجانيك كونتامينانتس. لكن الان اورجانيك دي ملهاش حل. يعني لو هي عاليه مثلا تريس ميتال زي الليد او الزنك او الكبر عالي في العينه ما بنقدرش.
ليها اوبتمايزيشن يعني في حدود معينه.
فيها الاي بي سي حضرتك بتعمل ليميت ليها. المفروض الزنك ما يزيدش عن تركيز 1000 بي بي ام حاجه زي كده. لو دخلت حضرتك على الاي بي سي سيرتيفيكيشن للان اورجانيك هتلقى كل التريس ميتالز بالتركيزات بتاعتهم.
سؤال تاني في الام سي اي اناليسيس يعني اللايف سايكل اناليسيس حضرتك ذكرت ايكويشن لكن لم توضح ايه ماهيه الايكويشن دي او حتى
اللي هي اللي تحت
الام سي اي اناليسيس.
احنا حطينا الايكويشن بتاعت الايكونوميك حضرتك صح؟
يعني لو بعض تفصيل بعد اذنك لو الوقت يسمح.
حضرتك تقصد المعادله دي صح؟ هي ببساطه خالص انا قلت لحضرتك انا مش متخصص في الايكونومكس. دي انا بعرفها من حاجه اسمها ان بي في نت بريزنت فاليو. دي المعادله اللي بتعرفني امتى المشروع بتاعي يبقى على الحياد، يعني مش بيكسب ولا بيخسر، امتى نقطه التعادل اللي انا عملت مشروع. دي ايه القيمه التسويقيه مثلا لو انا عايز ابيع البايو تشار في الكلايمت تشينج، ايه القيمه التسويقيه اللي انا اقدر اقول عندها مثلا $70 انا كده ما كسبتش ولا خسرت اقل.
هو ده سؤالي او بتاع الان بي بي انت قول ان الباي شارت ده كويس ولا استخدمه ايكونوميكالي او ما اقدرش من المعادله.
احنا بالنسبه للايكونوميك حضرتك بنعمل ايه؟ في سوفت وير هناك بتدخل حضرتك الداتا بتاعته، يعني الفيد ستوك، سعر الفيد ستوك، البرودكشن بروسيس بتاعتك بتكلف كام، بندخل كل التكاليف دي جوه وهو بيبدا يطلع لنا الان بي في. وهي مش بس الان بي في اللي هي بنقول المشروع بتاعنا هيقام ولا لا، لكن احنا في حاجات ثانيه زي الاي ار ار مثلا اللي هو الانترنال ريت اوف ريتيرن، امتى الفلوس بتاعتي ترجع لي. لو انا عملت المشروع في 2023 هاخد كام سنه لغايه ما المشروع يرجع لي. المتعارف عليه ما بين الاقتصاديين يبقى في 3 سنين، مش كتير يعني، ما يبقاش مثلا بعد 20 سنه الفلوس بتاعتها ترجع لي. فهو الموضوع ده بيتعمل بموديلنج دوت، يعني مش ما فيش حد بيحسبه باكسل، لكن دي المعادله بتاعته يعني. بالظبط حضرتك. زي ما قلت لحضرتك برضو انا عايز اوضح حته مهمه جدا. اي حد عاوز يعمل مشروع ناجح، انا زمان خالص لما كنت في جامعه جنوب الوادي كنت بشتغل كيمياء فيزيائيه فقط. حتى يعني ممكن كان تجي لنا افكار حلوه جدا، لكن علشان نعملها سكيل اب محتاج مالتي ديسبلينري تيم، محتاج تيم متعدد. يعني انا ممكن اعمل جزء الكيمياء، حد يعمل الانجينيرنج موديل، حد يعمل الايكونوميك، حد يعمل ال سي اي، ونتعاون كلنا عشان نطلع. لكن برؤيه واحده وبشغل واحد لوحده مش هيعرف يعمل الكلام ده.
شكرا.
الله يبارك في حضرتك.
يا أسئلة ثانية؟
شكرا جزيلا.